I'm going to talk about OMG modeling language standards. That is going to set the stage for things that are going to be talked about later today and into tomorrow. So what is a modeling language standard? Well, a modeling language standard is, not surprisingly, a standard for doing a modeling language, which is a language for writing models, which immediately leads you to the question, so what is a model? Well, we kind of know, but those are pretty models, but not quite what we're going to be talking about. These are models too. Now, that's not quite what we're going to be talking about either, but it's actually closer, and it's worth taking another look at this. Why do we call these models? I mean, you look at that, and that looks like an airplane, right? Now, you can pretty much tell that you're not going to be able to get inside that airplane. It's a model of an airplane, and it's a model of a train. But they're recognizably models of something, and they've got characteristics of that thing. That airplane has propellers. If you like airplanes, you know that it's a DC-3 from a Finnish airline in the 1930s. You can just look at that, and if you know about airplanes, you can tell, even though that isn't the actual DC-3. The important thing is it represents things about the thing being modeled. In that regard, these are also models. They're much more abstract models. That is also a DC-3, but that is now a picture, a blueprint of a DC-3. That's not a train, but it is a diagram of the tube system in London. The last one, well, if you're an engineer or a scientist, that actually is a mathematical model. It's called a model of the motion of a vehicle. So these are all models. They're much more abstract. They all represent certain things and have important characteristics about those things. And that's what we're going to be talking about. These are, in fact, the kinds of models we're going to be talking about today and tomorrow, and that OMG deals with in their modeling language standards. You don't point at that and say, hey, that looks like an online bank or online shopping system, but it has characteristics that are important for an online shopping system or for running your business. And that is the important thing about these models, is how you can use them to provide concrete representations of abstract things. So what is a model? A model is always a model of something. And it represents that thing being modeled. There are certain things that it represents faithfully and certain things that it doesn't. If it represented everything, if it was a copy of the thing being modeled, it wouldn't be a model, it would be the thing being modeled. The important thing is with a model airplane, we can carry that model airplane around. If I wanted to show somebody what a DC-3 looked like, I'd give them a picture or I could show them a model. It's much harder for me to bring a DC-3 with me to show people. It's the same thing. If I want to build a software system or if I wanted to design business processes, I can talk about it, but how do we actually represent it? Those are abstract concepts. I need something to make that concrete so I can communicate about it. So that's why we model. A model can promote understanding. It can be used to describe something we're studying. If you're an analyst or a scientist or even an engineer, it's very often the case that you will use models in order to take something that exists and analyze it, whether it's an airplane or a subway system or a software system. More importantly, though, for a lot of what we've been talking about, it can be used to specify something to be built or specify how to change something that exists. So you can model something that doesn't exist yet. That's actually done even with things like airplanes and cars, is building models of things that don't exist yet so we can build them. We're going to talk more about how you do that with software and with business processes, but actually, we're also going to talk about how you can model entire systems of hardware, software, and whatever. That's the important thing, is a model needs to be useful, and a useful model communicates important details about what it models. And it also, importantly, abstracts away from those things that aren't important. And that's the thing that is key. We want to be able to have ways of creating models that help us communicate. The model is not an end in itself. The model is, well, I mean, if you're a model train aficionado, I've known them sometimes, that is an end in itself. But a UML model, well, I've known some UML modelers where that's an end in itself too, but really we want a model that serves the purpose of communicating for describing an existing system or specifying what we want to do to build a new system. So what's a modeling language? right? You don't need a language in order to build a model of an airplane, but if you look at the more abstract models, they're pictures of things or they're text. So a modeling language is a language, a formal language for writing models, rather than just drawing block diagrams on a whiteboard or sketching them out in PowerPoint. It is a way to represent models that promote a common understanding. So when you write in a modeling language, the modeling language provides you with a way to make statements. And the model is a set of statements about the thing being modeled. Those statements can describe the system, or they can be used to specify the system. And that's the analysis approach and engineering or synthesis approach to using models. So they can represent and communicate for analysis and for synthesis. Just some examples of things. If you look back at what I was showing you, if you take a mathematical model, mathematics is a modeling language. It is a formal language used by scientists and engineers in order to write mathematical models. If you're a programmer, though, a programming language is also a modeling language. In the software community, we've often made a sharp distinction between things like UML, which are modeling languages, and things like C or Java, which are programming languages. And the reality is every programming language is also a modeling language in order to model how to carry out a computation. The computer doesn't directly follow what you write in the programming language. The programming language is a specification which, through a lot of steps, gets translated into something that can actually tell the computer what to do. And you're modeling that computation that ultimately gets carried out. But we're going to step up a level. OMG doesn't do programming languages, mostly not mathematicians, though we do have a mathematics special interest group and a number of formal languages people involved in OMG too. But OMG is best known for standardizing modeling languages that model software designs, entire system architectures, business processes, and quite a bit more. So why standardize these languages? Well, remember, what talked about models are meant to communicate. They're meant to promote understanding. Communication requires understanding. Right? We have to have a common understanding of the language we're talking in order to communicate, to express an understanding of what we're talking about. And that is what standards promote. They promote this common understanding across some community of users. That is what OMG is about, not just with modeling languages, but particularly important is modeling languages because they provide a platform to allow us to communicate understandings of other things. So let's talk a little bit about OMG modeling standards. OMG has a lot of modeling standards. There is a lot going on at OMG around modeling, and a lot of the things that Richard just talked about in terms of vertical or domain standards use the modeling languages, modeling standards in their work. But this really all goes back to 1997. Remember, OMG originally started, that's why it's called the Object Management Group, to do the Common Object Request Broker. It was a much more technical platform basis for building distributed systems and then defining domain standards. Again, it was about communication. It's a more technical level of communication, but it was about promoting common interchange and common interfaces for communications in distributed systems. The evolution really happened for OMG in 1997. And again, Corba's still around. There's still a lot of work that goes on at OMG on the distributed system platform. But UML really swept into OMG. The unified modeling language work led to the standardization in 1997. UML 1.1, the version numbering system hadn't quite been worked out back in 1997 for these new standards. It's actually very well worked out now what it means to have point releases and whatnot, but at the time, 1.1 was actually the first adopted standard. UML 1.0 was the first one that was submitted to OMG, and then it was revised before it was actually adopted as UML 1.1. That's why the first one here is 1.1. Between 1997 and 2003, OMG actually did 4-point releases, right? 5, including UML 1.1, culminating in UML 1.5 in 2003. There actually was not a whole lot that was done between 1997 and 2003 on developing actually full modeling languages. A lot of the focus was just on the evolution of UML. But around that time, some interesting things happened. The idea of a UML profile, which we'll see is very important for sort of the UML family of standards that grew up around the use of UML. The idea of a profile came to a fore. The idea of UML profile is this idea that you can specialize the language itself and use it for a specific community of interest. These are some early profiles, none of which are in use anymore, because these are based around early versions of UML. But they've all influenced later work. You'll notice that OMG basically is on a mission to try to use every letter of the alphabet at least twice in different acronyms. But you'll see, at least on this slide when I'm done, I'll have used every letter except 4, I counted. Z, we haven't used Z yet. We have used Q and V and X though. Anyway, SPTP has to do with schedulability, performance, and time. It was for real time. EDOC is Enterprise Distributed Object Computing, which was early enterprise computing. Profile, actually the term UML profile was actually created in order to write the RFP for EDOC. People don't remember. And EAI is Enterprise Application, boy, I did EAI. Integration. I had that in my title back then, and I can't remember anymore. The acronyms run out, these are old acronyms, but they've all influenced. You'll see going forward that we still have profiles for real time, we have profiles for architecture, and we have profiles for integration. Well, what happened after this? Well, there were 2 important things that happened around this time. First of all, we had a revision of UML. UML 2.0 was a major revision and an extension to the language based on a lot of experience with the UML 1.x series of standards. At the same time, we had BPMN 1.0. Richard mentioned the business process model and notation. That actually came into OMG when OMG absorbed the Business Process Management Institute. Well, after this, things started to heat up. So that really kicked off a lot of work. On the right, we have stuff that is largely derived from UML work, and I mean, on your right, no, your left. On this side, we have stuff that's largely based on UML, and on the other side is based on business modeling. Not to say that we don't talk to each other, but those have tended to be the 2 families of work that's going on. But that's not it. As if that wasn't enough, there's a whole bunch of other stuff in the background that has to do with meta models and meta object framework and other business motivation model. For some reason, 2008 seemed to have a lot of stuff. We were really busy that year. But you know, as if that's not complicated enough, I was going to put more on the other side, and I just said, no, I mean, they're already going to be glazed over at this point. So there is a lot going on in OMG in terms of standardizing. And these are all standards that are currently, well, all the ones after UML2 are currently still in use. Some of the older ones aren't, but you can see they have revisions. And I haven't even put on the point releases. After UML 2.0, I only put on 1.0 and 2.0 major releases. So there was work going on most of these on intermediate revisions. So you don't need to know all of this. Let me give you sort of the lay of the land for the major families of modeling languages that you can then take as a map in your head as you go and listen to the other talks in this event. First of all, we're going to talk about the unified modeling language. After the break, I have another presentation where I'll go through more about the unified modeling language. Let me just briefly say here that it is a very general language that is intended to provide system architects, software engineers, software developers with tool for analysis, design, implementation of software-based systems, as well as for modeling businesses and similar processes. Especially with UML2, this is kind of grown. It is best known, though, for modeling software systems. but it really, I personally used it, and many people have used it to model things beyond software systems, and it is the basis for things like the system modeling language, which model more than software systems. So what do I mean by modeling these sorts of things? Well, there's three basic kinds of diagrams. UML is a primarily, not entirely, but a primarily diagrammatic language with textual annotations. The first set is structure diagrams. Well known, if anybody here used UML for doing any sort of software design or see it? Yeah, so probably class diagrams, people are probably familiar. If you've used UML, that's the one a lot of people use that has to do with structuring the information structure of the system, the object-oriented structure of the system. But there are other diagrams around structures, such as the composite structure diagram, which gives you a logical breakdown of your system, and the deployment diagram, which lets you model the physical decomposition and deployment of your system. But UML is more than about just structure. There are a number of behavioral modeling capabilities. Activities are sort of the flow, the process-oriented modeling capability within UML. State machines is a state event-based model. They're actually very popular for a lot of engineering and real-time applications. And sequence diagrams, it's a little small and hard to see, but focuses on the interaction between parts. And then in requirements, there's use case diagram. Now, it's interesting. Use cases has come into the popular vernacular. You'll hear people on the street talk about, do you have a use case for that? Or a business person say, oh, I don't understand the use case for this, when they mean business case. So the use cases become generic, but it actually started in the work of Ivar Jakobsen prior to UML, and he was one of the main contributors that brought that into UML. A lot of people don't realize that in UML there is a very rich modeling capability where you can diagrammatically represent the requirements for a system using use cases and relate use cases. Now there are actually 13, I believe, different diagrams in UML, so there's even more than this, but these are the most common ones that you'll see used, and these are the ones I'll be talking more about later. But what I wanted to talk about was to use this starting point to talk about the family of standards that have built up around UML. Starting with UML, the first major standardized profile of UML was the system modeling language. So from the point of view of systems engineers, this is actually in many ways its own language, but it is technically a profile of UML, and the profile, as I mentioned before, is a tailoring of UML for use on a specific platform or domain. There's actually in the current UML spec, you can look at subclause 12.3 on the definition of what a profile is. I'm sure you're all going to run out and buy your copies of the UML spec so you can look this stuff up. But the system modeling language focuses, the community it focuses on is systems engineering. These are the guys that, especially on a big project, are the ones that have to bring together and integrate all the pieces, consider the overall systems design, do the optimization studies on more and more major systems, crossing hardware, software, processes, cyber-physical concerns. They need to bring that all together. SysML is now in version 1.5, and there is work currently going on for SysML version 2, which, if it keeps to schedule, will be, I think, 2020 should be seeing the submissions for that, the final submissions. The other major area that was standardized, now remember I mentioned the SPTP, the UML2 descendant of that is MARTE, which is the modeling and analysis of real-time embedded systems. It's currently in 1.1. I believe it is about to go to 1.2, and there is talk about a 2.0. Again, another very active community for describing real-time software. SOAML was a nice profile. It got to version 1.0.1. There's a reason why it's 0.1. That's not important. Unfortunately, there wasn't a lot of pickup of that one. The whole service-oriented architecture craze kind of passed over, even though there's a lot of good stuff, and that didn't catch on as much as the other ones. But it is still a available standard from OMG for modeling service-oriented architecture. Big one then was UPDM, the Unified Profile for DODAF and MODAF. As Richard also mentioned, this was very extensive profile that built a lot on SysML to not just deal with hardware-software systems, but entire enterprise systems, and to do a representation of all the different views that are in the architecture frameworks for the Department of Defense, for the Ministry of Defense, and through that, being able to do all those other AFs, the NAF and the DNDAF and the whatever. That has now evolved from, there was UPDM through, I think 2 point something. What was going to be UPDM 3, they said, you know, it's not so much about DODAF and MODAF anymore. We now really want to generalize that and talk about an architecture framework that can encompass whatever country or organization wants to put together a framework. So it provides a general way to model enterprise architectures in a consistent framework. And that's the UAF. It's currently in 1.0. That is the replacement for UPDM 3. And you'll hear more about that. I think 2 presentations this afternoon will talk about facets of UAF. Finally, I got to mention this because I've done a lot of work on this. This is that funny FUML. This was found, the name comes from the name of the RFP, which was Foundational Subset for Executable UML Models, which is a mouthful, and FISIUM was impossible to pronounce. So we shortened it to Foundational UML, or FUML. This is a subset of UML, and it focuses on the ability to actually fully define within this subset the semantics of execution, which means you can create a FUML model, and if you have a tool, you can actually define both the structure and the behavior of that model to the extent that you can actually execute it. And there's a number of tools that do that. You can take that and use it to generate software, actual running software, based on that full specification. But it turns out what it has been mostly used for is simulation, and with SysML, to be able to run simulations of systems models. And there's a number of tools now that are doing that, and there's extended capabilities for doing that. So we started with FUML. Then, remember, all the examples here of UML have been largely graphical. But if you're specifying detailed behavior, trying to do it in a graphical activity diagram, just gets impossible. Not impossible. I've seen people do some pretty extensive activity diagrams to fully specify executable behavior. It's really tough. So we defined a textual language, so at a certain level, you can write a language. It was designed to be familiar to people who do scripting languages or computer languages, but underneath, it has the semantics of UML. So it is a textual language for UML modeling within the context of FUML. And there is now continuing work. This is actually a very active area of continuing work at OMG. We have an additional standard called the Precise Semantics for UML Composite Structure. We adopted this term, Precise Semantics, which leads us to wonderful acronyms like PISCUS. But the idea is semantics is meaning. If you look at the UML specs, there's a lot of discussion of what these diagrams mean, but it's all written in text, which means it's hard to be precise, which is okay for a lot of modeling. But if you want to have true simulation and analysis and execution, you need a precise definition. FUML was started intentionally as a small subset. We extended that to add composite structure. Since then, we have also done work on having precise semantics for state machines. I didn't put it up here because it's not finalized. There's a finalization phase after a standard is adopted on OMG, and it's going to be finished to that by the end of the year. And we have started work on precise semantics of time, which is important for the SysML and Marte folks. All right, so that's the UML family of standards. Let me talk about the BPMN family of standards. BPMN is a notation. It's readily understandable by all business users, from the business analysts to technical developers to business people. So it's focused on talking about business processes, so it's not surprising that you've got something that looks like a flow. So the basic idea of a business process, you can see it's similar to UML activity diagrams, but it has a notation that is a bit richer around things like how you make decisions and events and the kinds of actions that happen in a business process. So the one on the left, that's the basic process diagram. That covers what's known as an orchestrated process, which means you follow this process. The one on the right is interesting because there are often cases where processes emerge. You can't tell people what to do. They don't just follow a process, but a process emerges because they all act together in a way that they've agreed to act, and by individually acting according to those norms of the protocol, you get an emergent process, or what's known as a choreography. So it's the difference between a conductor running an orchestra and a choreographer who talks to individual dancers, and then they work together. And the choreography diagram has less to do with following a process and more to do with messaging and communication between the various performers. Then there's also higher level diagrams. The collaboration diagram talks at a high level about how a process works across collaborating entities, and a conversation is a high level choreography which abstracts up to the level of not just abstracts up from the level of detailed messaging to what conversations have to take place between the performers for the goal to be achieved. So again, there will be a discussion about BPMN later on, as well as other languages that are in this, what I call the BPMN family of standards. Now, unlike UML, BPMN doesn't have a profiling mechanism, and this community has not taken BPMN and then adapted that specifically. It is already adapted for the specific goal of business process modeling, but there's other things you need to model about a business than business processes. So the next thing that was done, and you can see a commonality of acronyms there. We have BPMN, and CMMN. So this is the case management model and notation, which is complementary. If you're involved in some of these business areas, you know that a process, you move through a process and follow certain steps. But there's often cases where you have to deal with cases. That is more collecting information and then reacting to the information. I worked, for instance, on a system that had to do with adverse drug effects. You got a report of an adverse drug effect and then had to gather information on that. And based on that information, you need to contact certain regulatory authorities. So you had to deal with this evolving case. When you're doing an investigation or when you have a legal matter. So this is a notation for describing the things that need to be done around managing a case. In all of these things, you have to make certain decisions. So in the business process model, at certain steps along the way, you need to make a decision. The DMM is a notation for describing how to make those decisions in a way that's understandable and can be automated. So all of these work together. This is what Dany Gagné, who we'll talk later, calls the triple crown of the business modeling language community. They work together in order to allow you to do a complete business model in a way that's understandable, but also a way that's automatable and executable, which is, has been from BPMN onwards important for this community. Enactable, I should say. Complementary to that triangle of standards is another one called VDML, which is the value definition modeling language. That's fairly recent, that's in version 1.0. It is for general analysis and design of the operation, so it is more at the enterprise level, and it focuses on how you generate value from the enterprise. So the VDML provides you with that high-level view of how you want to generate value, and it is then complementary to designing your processes or managing your cases or making your decisions in order to get that value. That is part of an overall business architecture modeling approach. There is work going on for more extensive modeling capabilities for business architecture, and Bill Ulrich will talk about that either later, I think later today. So that is the roadmap for modeling languages. Where do you want to find more? OMG has an extensive catalog. The areas that I looked at specifically or that I showed you specifically, are in the categories of modeling, business modeling, and enterprise modeling, not surprisingly. So you can find the specifications for all the standards that I talked about by following those links, and there's a table and it'll list everything. But if you want specifically just resources about UML or BPMN, including links to some of the other standards that I talked about relative to those base standards, you can go to uml.org or bpmn.org. That's easier to remember. So you can use that as the starting place. Okay, I'll be happy to take a few questions.
Do all of, you showed the alphabet soup slide you showed, do all of these standards fit together? What's the coherence of the family of standards?
So within the family of standards of UML, because they're based on the underlying UML, there is some consistency. It's not entirely for various technical reasons, but one of the reasons to do profiles is that there are many UML tools where you can plug in a profile. So you can get a generic UML tool, and it can also do SysML or BPDM because they're all based on the underlying UML. With the BPMN set of standards, they have been developed together. Starting from BPMN, the other ones have been developed with meta models that fit together. So you can have tooling that fit together. Some of the other standards, there were a lot of others. They have various levels of integration. And it's really hard when you've got very active communities at OMG coming and contributing and wanting to do their piece. The OMG Architecture Board has a tough job of reviewing all this and trying to make sure they fit together, like anything else. Does better sometimes and not others. UML2 has now been around long enough and has so much work done on it in profiles that we're starting to hit the limits, and we can see where the rough edges are. The work in business modeling is still continuing, and that's all working within one task force, and they are doing a good job. But we've got all these domain groups that are also producing the things. So it is somewhat of a mixed bag. That's one of the reasons I wanted to focus on these families, because they're the ones that have the most coherent set of standards around them. But there's some underlying platform standards like the MOF, which I didn't want to get into because it was more technical, the Meta Object Facility, which does underline all of these languages.
I'm just wondering, when you're defining your own roadmap for different work on different standards and specifications, how do you monitor to establish need? How do you set priorities?
In the standards development groups? That's a good question, because the only way we can do that is by people from the community coming to OMG. So OMG does not have a big staff. They have a very hard-working staff, but it is a small staff because it is a member-driven organization. And the members come. What OMG provides is support for a process that allows you to reach a consensus on what needs to be standardized and then review and approve to the standards. So the OMG is structured into two main technical committees on the platform and the domain side, and within that they have a set of task forces, which have ended up being fairly standing task forces. There's no fixed membership in the task forces. Any OMG member can go to any task force, but UML, for instance, came out of the Analysis and Design Task Force, which is a legacy name. It does more than that now. And that has a mailing list, and then it meets at these technical meetings every 3 months, and people come. And one of the main things we do at these meetings is review where development efforts for standards are and talk about what to propose next. These task forces will all set up working groups. For instance, the work on executable UML is in the executable UML working group, which is an informal group set up off the Analysis and Design Task Force to talk about what to do next. The reason we're doing precise semantics of time next is because we got together and said, should we do precise semantics of interactions or time, or what do we need next? And the people who are a combination of vendors and users who are interested came and said, we need these things. That's how UPDM has developed into UAF. That's how SysML, which actually came out of the System Engineering Special Interest Group, which is a more formal group. So a working group's informal. If you have a continuing interest, you can set up a formal special interest group that specifically talks about these roadmaps and generating RFPs. A special interest group doesn't generate an RFP, but they can go to the task forces to ask, we need to put out an RFP to ask for this new standard. So that's how it works. It is by becoming a member of OMG, coming and participating, that you set the roadmap, and that then, that work results in requests for proposals going out for new standards, and then the members contribute the proposals, and there's a process for reviewing and adopting them.
And do you want to say something about how discussion papers and RFIs sometimes can be used to also?
That's true. That's a good point. I was focusing on coming here to OMG because a lot of what I've been involved with in terms of roadmaps has been in standing groups here. But often you'll be getting into a new area, or you feel you don't have the representation in the membership at OMG that you need in order to make a decision. So OMG members can use the groups here to write discussion papers or white papers that are informal papers that are then distributed publicly. There could also be a more formal process to put out a request for information. For instance, when UML 1.5, 1.x series was getting to the end, and they weren't quite sure where to go with UML 2.0, the group, considering the ADTF, put out a request for information, not just to the members, but to the entire software community, basically saying, if we did UML 2.0, what would you be interested in having in it? So that is a more formal mechanism to gather information outside the membership. But even deciding to do RFIs and discussion papers, you have to be a member, you have to be here to do that, then that provides a vehicle for gathering more information beyond just what membership is participating. That was a good point. Thanks, Claude. Other questions? Thought I saw another hand.
We have standardized on Archimate, and I wanted to know if there is a strategy for integrating, combining UML.
There is, in fact, a UML profile for Archimate. That's fairly recent. Has that gotten adopted? That's gotten adopted, has it? Yeah. So we actually, that was our, interestingly enough, there's a UML profile for BPMN too that integrates across them. So there has been discussion between Archimate is Oasis, Open Group, sorry. Between the Open Group and OMG, they have a liaison relationship for discussing their standards, and work was done recently. This was a process where actually representative from the Open Group came in and talked about Archimate. There were some people who were interested in how to integrate the use of Archimate with UML tools, and it was proposed to do a UML profile for Archimate. There are some interesting IP issues with the Open Group that were then worked out, which is an important thing the group, at this level, the groups can work out, and now we have that. So I don't know, I don't have any personal experience with using that, but that was the strategy. It's fairly new.
Just wondering why OMG had never gone down the path of standardizing for higher level and lower level within information and data modeling.
They're actually, okay. The question was, why hadn't OMG gone down the path of standardizing in higher level and lower level data modeling? Actually, it has, but it got kind of stuck. So there was an early, if you look back on my chart, there was an early model called CWN, which was Common Warehouse Meta Model, which was basically the idea was to come up with a way to model data warehouses, which were popular at the time that this was done. When that was done, that was actually fairly early. That wasn't a profile of UML. It was a separate language. It got some pickup, but not a whole lot. But what was realized was, well, you don't really just want to model data warehouses. You want to do data modeling of all sorts. So an RFP went out for information modeling meta model, IMM, which I believe still does not have a final specific. It kind of got too big. It is the longest. I think this process of working on that proposal is like 7 or 8 years now. I think it's sort of the longest that people have like spent their career trying to finish that, and unfortunately it hasn't gotten done. This is, I'm honest about this because it's one of the downsides when you have a member-driven organization is that things get done when you get the members to get them done. And this IMM just hasn't been driven to the finish line, so that's kind of unfortunate. It is very common, though, for people to use UML and profiles of UML, even if it's not standard, to do data modeling at various levels. So it depends how you mean what levels are, but IMM, for instance, had a way to model XSDs, as well as relational database models, as well as entity relationship models, and relating those to OO models. So it was very comprehensive. There are pieces of that, even though they haven't been standardized, that people have pulled out and used, like a UML profile for XML schema, or a UML profile for relational databases. It's just unfortunate that for various reasons that has not actually become a formal standard yet. Okay, thank you very much.